everyone, my name is Abha Putra. I am pursuing BTech CSE from Bennett University. I hail from a small town, Ratlam, MP. I have secured 94.6% in my CBSE boards and 95th percentile in JEE Mains. My craze for robotic engineering and an excellent experience of my elder brother, Abhi Bothra, stimulated me to join Bennett University. It offered me more than my expectations. I have been awarded 100% scholarship which boosted my self-esteem. Bennett gave me an opportunity to be a core team member of Technotics, the robotics club. It is a place which not only focuses on intellectual development but also focuses on holistic development. It was Bennett where I first got the opportunity to donate blood and serve the mankind as an individual. I was a state level swimmer before digging my head into studies. With the help of sports PU, I started swimming again. Being a Bennettian helped me to explore the fields of computer science at a very early age. It helped me to explore fields like AI, ML, cloud computing, big data. I never thought that our ideas would be a paving stone for an upcoming industry. But when my project was selected for Industrial Expo in my first sem itself, it gave me a sense of confidence which I always felt that I lacked in.
Today, in this world of cutting-edge technological development, when human lives are becoming easier day by day, people begin to believe that no obstacle is difficult for a machine to solve. Yet, there are a large number of problems which machines are not able to solve from a very long time. So, in order to reach our goal for a fully formulated smart environment, a small world where various types of smart devices can work tirelessly to make people work and life more easy, comfortable with sense of security which can be possible by IoT, AI and ML used together. So there is an ever desired need for a machine to think and act like a human to achieve the goal for a fully formulated smart environment. Hence, we are going to discuss what is Turing machine, the role of Turing machine in smart environment, what are the issues in formulating the machine, and the critical challenges we are facing while implementing the idea. Every machine is different from one another with respect to their respective function. Therefore, it is important to have a standardized computational theory which can be used by all standard machines. There are various types of models of computer machines like non-deterministic finite automata (NFA), deterministic finite automata (DFA), push-down automata (PDA), deterministic push-down automata known as DPDA. But none of these are as effective as a real machine or computer. Therefore, we need a model which can be used in place of all other standardized models. This model is known as Turing machine. Turing machines. Turing machines were first described by Alan Turing in Turing 1936 to 1937. Are simple abstract computational devices intended to help check the scope and restriction of what can be computed. From the past century, science and technology are going through many changes. Artificial intelligence has approached computer technology to enhance its evolution. Artificial intelligence has created a dilemma among humans as artificial intelligence has changed the idea of man towards machine as it acts like a human brain, therefore it is also called man-made intelligence. Artificial intelligence acts on a machine to perform intellectual operations. So, if these cognitive or intellectual operations can be described in the form of algorithms, then they can act like a machine cognitive function. So, what people think of computation is some kind of stuff what the computers do, which is basically connected from the notion of Turing machines or a concept of logical system. Some people who criticize artificial intelligence assume that the Turing machine and its computational model is based study for the computers in artificial intelligence and intellectual cognitive sciences, which is of matter of fact that people think that there are theorems which shows the limitation of Turing machine. This suggests that the wide-viewed goal of artificial intelligence cannot be achieved. So basically, artificial intelligence is used to construct a learning algorithm that can be run on a machine such as human brain, that is general purpose computational machine. So artificial intelligence is a tool to build real intelligent machine. The neural networks make a small family of artificial intelligence, therefore human brain is also called as BNN, biological neural network. Computer programs make use of three fundamental mechanisms: elementary operations, logical flow control, and external memory, which can be written to and read from the course of computation. Despite its wide ranging success in modeling complicated data, modern machine learning has largely neglected the use of logical flow and external memory. Recurrent neural networks (RNN) stands out from other machine learning methods for their ability to learn and carry out complicated transformation of data over extended period of time. Moreover, it is known for RNN are tuning complete and therefore have the capacity to stimulate arbitrary procedures if properly wired. Yet, what is possible in principle is not always what is simple in practice. We therefore enrich the capability of standard recurrent neural networks to simplify the solution of algorithm tasks. This enrichment is primarily via large addressable memory. So, by analogy of Tuning's enrichment of finite state machine by an infinite memory tape, we have dubbed our device a neural tuning machine, (NTM). Unlike a tuning machine, an NTM is a differentiable computer that can be trained by gradient descent, yielding a practical mechanism for learning program. The main aim of neural tuning machine is to design a computational model which can fulfill the objective of AI by designing learning algorithms can be worked such as the brain of the human. The new neural learning technology in artificial intelligence is called as deep learning, which tries to manage the cognitive problems and provide a system where human brain-like pattern can be observed. NTM are also greatest discovery which contributes a lot towards machine learning. It opens the various options by which machine learning can be used to learn various algorithms which can access an external memory. Here is a diagram of architecture of smart environment with artificial intelligence given. Deep learning is a part of neural networks. Neural networks is a part of ML. ML is a part of AI, and AI finally consists of smart environment. How do we know that the machine is thinking like a human? Can a machine really think like a human? If yes, how do we know it? What is the criteria when we can say tuning machine is acting like a human? So, in order to resolve all these queries, Alan Turing in 1950 came up with a theoretical notion called Turing test, which has to be given by a tuning machine in order to test its intelligence. According to his proposed methodology, a machine with other human candidates will be made to sit in a room. An examiner who will be notified that among all the students there is a machine, and you have to identify who is that. The examiner will ask them questions in only written form. So, in the end, if the examiner fails to tell who is a machine, then this test for intelligence is considered to be passed, otherwise fail. Similarly, there is also a test in which the roles are reversed, like the examiner is a machine and the candidates are human. Such test is known as reverse Turing test. There are many challenges which we are facing in smart environment technologies. One of these challenges is to make machine think like a human and act like human so that they can make a good decision when in case a human is not available. It requires a large computational power for algorithms. Machine learning and deep learning are two major pillars of AI, and they have vast and complex computational requirements. For a model to perform high performance and accuracy, it requires smart optimization, large dataset, and most important, a well-furnished correct algorithms with high computational power. It also requires a lot of training and testing, and it is 1,000 times more than it looks. Deep learning and machine learning models are based on the fact that a large amount of data is available to train them at first place. Let's suppose we have that data, but then it creates the issue of data privacy and security. For example, suppose an organization is working in a city and it manages the data of a large number of people. But due to cyber attacks, all the information regarding the residents of the city who are serviced by the organization, including the personal information, is leaked. The leaked information of personal info into the hands of people on the dark web creates a security concern for the people. So, we cannot totally neglect this possibility. But nowadays, techniques have been introduced to tackle these concerns, like we can train the models on smart devices and can make sure that the data is not sent back to the servers. And ultimately, after training part is complete, a complete trained model is sent back to the respective organization. But it still has its own pros and cons, and also it does not completely eliminate the problem. Other major problem that the AI is facing is to remove the biased nature of an AI system, because it depends on the category and amount of data they have trained on. But if we talk about good AI, then it should have a good data to feed on. Now, as a matter of fact, majority of the data that organization hold is poor and has no importance on its own. Therefore, we can say that they are biased in nature, as they define the interest of the limited number of people. So, in order to solve the problem, we have to make sure that some algorithm is defined that can productively check these kinds of problems. Issues associated with Turing test and artificial intelligence. As we have already discussed the working of Turing test, so Allen asserted in his paper that by the starting of the 21st century, ideally programmed digital computers will be considered like a human brain prototype, as the test will show the machines think before answer the questions posed by humans. In order to accept the notion, the machine will need to pass the Turing test. Turing's ideal of defining whether the machine think or not was really impressive, but at the same time it also posed a lot of issue which questions its credibility. First, Turing test did not define the detailed test characterizations like number of observers, whether any qualification required or not, lengths of test to be taken. So basically the test did not take into account a lot of more characterization by which we can say the machine actually thinking like a human. Second, so in order to solve these challenges, there were various ideas like by the test we only check if the machine can answer the question of humans in familiar and rational way, then we can surely say they are thinking. But this assumption was not taken into account because a chat can tell us about the machine thoughts, but it cannot tell us whether it is thinking being or not, because we humans take a lot of factors into consideration like appearance and consistency in response, like being logical and forming a unified whole conversation in a consistent manner. So we can say that what Turing meant by thinking was mainly focused on prediction, so people can use the word thinking in this context. So the real question which arises, that is this really thinking what the AI assumed it to be? So we can say in aspect of machine to be called thinking like a human, Turing machine with old definition cannot be valid criteria to call a machine to be a thinking machine, because it possesses a lot of question and contradiction. Suppose we are playing a chess game with a high level computer. What do you think? Will you be able to distinguish between a machine and a human? The answer is clearly no. So basically, what we understand from the discussion is that the aspect of thinking is not to give correct answer, but sensitive answer, also called responsive answers. So by consideration this argument, no machine has ever come in touch even with the boundary of real thinking. The discussion of the above problem poses a great challenge for artificial intelligence admirers. People and organizations have made very high level programs and softwares like Amazon Alexa, Apple Siri, Google Assistant, which tries to do interaction with humans, provides various answers like another human being is talking to them. But even they are not able to pass the actual tuning test. So now the real question arises whether tuning test can be considered a valid test for artificial intelligence. The answer of this question is unknown in the world of artificial intelligence because tuning at least shows some theoretical way of proving whether machine can be called as thinking or not. Apart from him, nobody till date has given any alternative ideas about AI providing its claim of thinking like a human brain. So we can say if there is no boundary, then it will be impossible to say that it is fit to be an artificial intelligence and what is not fit. So basically, without the proper rule, every second app software is nowadays called an AI, even it nowhere resembles features of AI. After going through so many variations and alternatives to find the ideal test rule to define the artificial intelligence existence, the original version of the rule is still used today. Likewise, from 1991, Hugh Loban, a New Jersey-based businessman, started the Loban Prize distribution in AI, in which the aim was to choose the winner team of the year on the basis of AI, which can perform as nearest as Turing explained it. From this year, this competition is held every year to choose a machine who act like a human by following the Turing test standard rules. So, after much discussion about Turing test pros and cons, its variation and alternatives, the Turing test still exists today as old wise men, which gives valuable and starting lessons as and provide a platform for debate and reviewing AI. As we are going deep in artificial intelligence day by day, but a foundation of AI remains same by explaining intelligence and is stating points for debating. What should be our technology test which makes ideally and virtually possible to call machines as thinking brains? After all, I can say one thing about validating a strong AI that only criticizing tuning machine is wrong and should be stopped immediately because people don't have any other idea which can prove and answer the real question whether machine think like a human brain, and they just want others to leave the only available idea which may also not be able to tell the answer, but still it is a very good test for intelligence and possibly the only option which is available. So basically, we are improving the machine day by day, and I believe that by gaining the technology from these machines, we will be able to find the solution to correct tuning test. It's always better to believe in hope and rather living in uncertainty.